Hey everyone, Mr. Phil's avatar here with another devlog update. Today I'm covering a critical day of validation and bug hunting for Stellar Throne, my 4X strategy game. For those just joining, I'm building this with Godot for the UI client and Zig for the high-performance simulation engine. After getting the Zig backend enabled in production over the weekend, Monday was all about making absolutely sure the two engines stayed in sync. The big picture context. I now have a working dual engine system where the Zig simulation runs 52 times faster than the original Godot implementation, but speed means nothing if the results are wrong. So Monday's mission was validation, testing, and fixing any divergence between the two engines. The day started with fixing a fleet position serialization bug. The issue was subtle. When fleets moved between star systems, their positions would be stored correctly in the Zig simulation, but when the data came back to Godot for rendering, the position interpolation was broken. Fleets would jump around the screen instead of moving smoothly along their travel paths. I tracked this down to the serialization layer. The Zig engine was outputting fleet positions in one coordinate format, but the Godot rendering code expected a different format. I fixed this by standardizing the position serialization and ensuring the movement interpolation code properly handles the data structure coming from Zig. With that change, fleet movement became smooth and visually correct. But I knew I needed more than ad hoc bug fixes. I needed systematic validation. So I dedicated this phase of work to building comprehensive serialization parity tests. The goal was simple: catch any data structure mismatch before it causes a production bug. I implemented a test infrastructure that compares the Zig and Godot engines after every operation. The tests serialize game state from Godot to JSON, deserialize it in Zig, run a simulation step, serialize the Zig results back to JSON, and then compare every single field to make sure nothing was lost or corrupted during the round trip. This framework caught several subtle bugs immediately. There were inconsistencies in how Empire resources were formatted. There were edge cases where planet population data would round trip slightly differently due to floating point precision. There were fields that weren't being serialized at all in certain scenarios. I spent the rest of the day fixing these format inconsistencies. The serialization code became tighter and more defensive. I added explicit validation for every numeric field to ensure precision is preserved, added null checks for optional fields, and introduced default values for any fields that might be missing in older save files. The parity tests now run after every code change and verify that Godot and Zig produce identical results for the same inputs. This gives me confidence that the dual engine architecture is sound. Then a new challenge surfaced: population growth parity. The parity tests were passing for most systems, but population numbers were diverging between the engines. A planet would grow population correctly in the Godot simulation, but when the same turn ran through the Zig engine, the growth rate came out slightly different. This was concerning because population growth is a core game mechanic. If players see their planets growing at different rates depending on which engine is running, the game feels broken and unpredictable. I added debug logging to both engines to trace exactly how population growth was being calculated. The logs revealed the problem. The Zig engine was using integer math for an intermediate calculation that should have been floating point. This caused rounding errors that compounded over multiple turns. I fixed this by converting the intermediate values to floating point before the multiplication. The population growth formula now produces identical results in both engines, down to the last decimal place. But the floating point precision issue went deeper than just population growth. As I continued testing, I discovered a problem with the test infrastructure itself. The asynchronous turn processing code was creating race conditions. A test would start a turn, check the results too early, and fail because the turn hadn't actually finished processing yet. I fixed this by adding proper weights in the test sequencing code. Each turn now fully completes before the next test assertion runs. The test became more reliable and stopped producing false failures. Then I uncovered another floating point precision bug, this time in the maximum population calculations. Planets have a maximum population determined by their habitability score. The Godot code was using single precision floats, while the Zig code used double precision. This caused the maximum population values to differ by tiny fractions, which accumulated over long playthroughs. I standardized both engines to use double precision floating point for all population calculations. The max population values now match exactly between Godot and Zig. The day ended with debugging a star rendering issue. After running turns through the Zig simulation, some stars weren't displaying correctly on the galaxy map. The investigation is still in progress, but it points to a coordinate transformation problem in the rendering pipeline. Let me give you the technical breakdown. Monday produced 10 commits. The serialization parity framework added 327 lines of test infrastructure. The population growth fixes touched 4 files with 81 lines changed. The floating point precision fixes modified 6 calculation functions across 3 modules. The async test infrastructure improvements added 53 lines of proper sequencing logic. The parity test suite now includes 15 different validation scenarios. It checks empire resources, fleet positions, planet populations, star system states, and cross-turn consistency. Every test runs both engines side by side and compares their outputs field by field. Current status: the Zig simulation backend is running in production with comprehensive parity validation. Population growth is identical between engines. Serialization round trips are verified by automated tests. Fleet movement is smooth and correct. The only remaining issue is the star rendering bug, which I'll be tackling next. This validation work might not be as exciting as adding new features, but it's absolutely essential. The dual engine architecture only works if both engines produce identical results. These parity tests give me confidence that the 52 times performance improvement isn't coming at the cost of correctness. Next steps: finish debugging the star rendering issue. Add more parity tests for edge cases like empire bankruptcy and fleet combat. Start profiling the Zig engine to identify any remaining performance bottlenecks, and begin thinking about how to leverage the speed improvement to add more complex simulation features. That's the development update. Check out MrPhilGames.com for more. Thanks for watching.